A ladder 9 meters in length is leaning against a vertical wall on level ground. As the bottom end of the ladder is moved away from the wall at a constant rate of 2 meters per second, the top end slides downward along the wall. How fast, in meters per second, will the top end of the ladder be sliding downward at the moment the top end is 3 meters above the ground? Okay, so let's draw a figure of what's going on here. So we have a ladder leaning against the wall like this. The length of the ladder is 9 meters. And as this point slides that way, this point will slide downwards that way. So I'm going to call this distance x. And then we should, clearly we then have this value, which I'll call h. We have h is equal to 9 minus, 81 minus x squared square root. Maybe instead of doing it like that, I'll just write down the relation that they satisfy. Rather than having the square root everywhere, we might be able to get through this problem without using a square root anywhere, or at least not till the very end of the problem. Now this point is moving in that direction at a speed of 2 meters per second. And we want to figure out how fast the top end is sliding downward. Okay, so what I'm going to do is I'm going to think of h as being a function of x. So I have x squared plus h of x squared is equal to 81. In fact, maybe I should even think of everything as being a function of t, so that x is also a function of t, h is a function of t. Yeah, in fact, that is what I'm going to do. Let's say everything is a function of t, like this. So I have x squared t plus h squared t is equal to 81. The reason it's better to do it this way is because I'm looking for the speed of the top of the ladder. That is essentially h prime of t. We don't want h prime of x, we want h prime of t. Okay, so if I just take a flat out derivative of this using implicit differentiation, I have 2xt times x prime t plus 2h of t h prime t is equal to 0. Now we know that x prime of t is equal to 2, so I have 4x of t plus, we're also told we're interested in a particular value in time when the top of the ladder is 3 meters above the ground. So h of t is going to be equal to 3. This is equal to then 6 h prime of t. Now I want to solve for h prime of t, but also we're going to have to solve for x of t, knowing that this is always true. So I have 2x of t plus 3 h prime of t is equal to 0. And if I rearrange this, I have 3 h prime of t is equal to negative 2 x of t. 3 h prime t is equal to negative 2. Now x is equal to 81 minus h squared under square root. And once again, on the right-hand side, we're told that h at the time we're interested in is equal to 3. So this is 81 minus 9 under square root. And now we're just doing some simple algebra arithmetic. So 72 square root. 72 is 9 times 8. So I have 3 h prime of t is equal to negative 2. 3 times the root of 4 times 2. Okay, so 3 cancels. I have h prime of t is equal to negative 2 times 2 times root 2. So h prime of t is equal to negative 4 root 2. So this says that option C is correct. The negative sign, of course, just means that the top of the ladder is moving downward. So the speed is just positive 4 times root 2. Yeah, I don't think there's too much more to say about this one. Let me maybe highlight what the important key points were. Of course, writing down the relationship between x and h, this was used multiple times through this problem. That just comes from the Pythagorean theorem, of course. And then if I think of the positions of the top, the bottom and the top of the ladder as just being functions of t, then realizing that derivatives of position with respect to time give velocities, and we're interested in the relationships between positions and velocities here. So taking a derivative of this expression with respect to t using implicit differentiation pretty much means that everything we want kind of just pops out into this expression. We know x prime of t is fixed at 2. The question says it moves away from the wall at a constant rate of 2. This is what we're actually solving for, the speed of the ladder itself. And we're told what that is, and we can use what that is to solve for what that is. And so we just have everything. Yeah, nice little question. If I have anything else to say, I'll write it down in the description. Thanks for watching.